Hello, everybody. So today we're going to be working with patterns with fractions using what we've learned about adding fractions with unlike denominators and subtracting fractions with unlike denominators. So we're on page 287 of the fifth grade Gold Math textbook. And so our essential question is, how can you use addition or subtraction to describe a pattern or create a sequence with fractions? All right, so Mr. Patrick wants to develop a new chili recipe for his restaurant. Each batch he makes, uses a different amount of chili powder. The first batch uses 3.5 ounces. The second uses 4 5/6 ounces. And the third uses 6 1/6 ounces. And the fourth uses 7.5 ounces. If this pattern continues, how much chili powder will he use in the sixth batch? Okay, well, we can find the pattern in a sequence by comparing one term with the next term. So we're going to write the terms in the sequence as equivalent fractions with a common denominator. And that way we make it easier for us to go from one fraction to the next. Then we're going to examine the sequence and compare the consecutive terms to find the rule used to make the sequence of fractions. So if we have start at 3.5, and then it goes to 4 5/6, then 6 1/6, and then 7.5. Well, the halves to six might become confusing, and you might not recognize the pattern. So let's change it to the same denominators. So 3.5. Well, 3.5 times what equals something with sixths? Well, if I multiply both of them by 3, I would get 3/6. So 3.5 is the same as 3 1/6. So let's rewrite this. 3 1/6. Then it went to 4 5/6. So how much did it add to go from this to this? Well, I see an increase of 1 in the whole number, and I see an increase of 4. Oh, I'm sorry. I didn't think that made sense. 3 3/6 should be the same as 3.5. Okay, so 3 3/6 is the same as 3.5. So the first batch rewritten as 6 is 3 3/6. If we add 1 2/6 to that, we get 4 5/6. Then the next one in the pattern is 6 1/6. So how much do we add to go from 4 5/6 to 6 1/6? We'd again be adding 1 2/6. Okay, and we can prove that by adding 1 2/6. So 5/6 plus 2/6 is 7/6. 4 plus 1 is 5. Well, we know we can't leave 7/6 as an improper fraction, so 7 divided by 6 would be 1. We have 1 left over, so 7/6 is the same as 1 1/6. So 5 7/6 equals 6 1/6. Okay, all we're doing is adding the 1 1/6 to the 5. All right, so that we get 6 1/6. And then if we add another 2/6, 1 2/6, we'd be at 7 3/6. All right. So what rule describes the pattern in the sequence? First off, is the sequence increasing or decreasing? Well, 3, 4, 6, 7, it's increasing, right? So the pattern is increasing by 1 and 2/6, or if we simplified it, it would be increasing by 1 and 1/3. So what's the rule? Add 1 and 2/6, or add 1 and 1/3. So now let's extend the pattern to find the 5th and 6th batches. So we were at 7 and 3/6. We were at 7 and 3/6. And we're going to add 1 and 2/6. So 7 and 3/6 plus 1 and 2/6. That would give us 8 as the whole number. And 3/6 plus 2/6 is 5/6. All right, so 8 and 5/6. And then we have 8 and 5/6 plus 1 and 2/6. Well, 5 and 2 is 7. So 7/6. And 8 plus 1 is 9. Now 7/6, again, is a improper fraction. And we know from earlier that 7/6 can be rewritten as 1 and 1/6. So 9 and 7/6 equals 9 plus 1 and 1/6, or 10 and 1/6. So Patrick will use 10 and 1/6 ounces of chili powder in the 6th batch. Okay, you notice that when we rewrote the pattern, the last two numbers, we put it back in the original sequence. Okay, so what we're doing when we change it to common denominator, that's just to help us add the numbers. We do want to go back and put them in simplest form. All right, let's look at page 288, number 1, the example. So find the unknown terms in the sequence. So I see we go from 1 and 3/4 to 1 and 9/16 to 1 and 3/8 to 1 and 3/16, and then we got to find the next three terms, and then it goes 7/16 and 1/4. Well, it looks like it's decreasing, right? So step 1, let's write the terms in the sequence as equivalent fractions with a common denominator. So let's look at all of our denominators. We have 4, we have 16, and we have 8. Right? So what is a common denominator to all of those? Well, I'm going to start with the 4. 4, 8, 12, 16, 20, 24. Okay, I'm going to stop there. 16. The first one of 16 is 16, 32, 48, 64, 80, 96. And 8 is 8, 16, 24, 32, 40, 48. Okay, well, what's the least common denominator or least common multiple in common to all three? 16. So let's change these to 16ths. So 1 and 3/4 times 4/4, because 4 times 4 is 16, we would get 12/16. So 1 and 3/4 is the same as 1 and 12/16. Then the next number was already in 16ths, so 1 and 9/16. Then 1 and 3/8. 1 and 3/8 times 2 over 2 is 6/16. So 1 and 6/16. Then 1 and 3/16. And then we're going to get to our three blanks. And then jump to 7/16. And it finishes at 1/4. 1/4 times 4 over 4 is 4/16. All right, so what operation can be used to describe a sequence that increases? Well, that would be addition. If we're increasing the pattern, it's increasing. If a pattern is decreasing, it's subtraction. Okay, so what's the rule in this one? Well, let's see, 12/16, 9/16, 6/16, 3/16. It's getting smaller. So subtract how much? Well, 12 take away 9, that's just 3, right? So 3/16. Use your rule to find the unknown terms, then complete the sequence above. All right, so 1 and 3/16 minus 3/16. Well, 3/16 take away 3/16 is 0. So 1 plus 0, 1. Now we have 1, and we're going to take away 3/16. Well, I can regroup the 1 as 16/16. 16/16 take away 3/16 is 13/16. And 13/16 take away 3/16 is 10/16. 10/16. All right. Now, how can we rewrite these in simplest form? Well, the 1, we're just going to leave that as 1. 13/16, 13's prime, so I can't rewrite that. But 10/16, I can simplify 10/16 by dividing by 2. And that's going to leave me 5/8. Okay. So the missing numbers were 1, 13/16, and 5/8. And I'll write underneath here 10/16 is the same as 5/8. And 1 is the same as 16/16. All right. So let's try the next one. So we have 1 and 1/12, and then it goes to 5/6. And then we're missing a number, and it goes to 1/3, and then 1/12. Well, I noticed that the denominator between these two, the denominator is bigger. So that means that the fractions are getting smaller. So we're going to be subtracting in this problem. So let's see. We need a common denominator of 3, 6, and 12. We should notice what it is right away, right? But let's put it a list just in case. 3, 6, 9, 12. Well, 6 can become 12, and 12 already is 12. So we're going to turn these into 12s. So 1 and 1/12. 5/6 times what is 12s? 2, right? So 5/6 is the same as 10/12. 1/3 times 4 is 4/12. And we finish with 1/12. So this is the easier one to notice. 4/12 to 1/12. That's subtracting 3/12. So 10/12 minus 3/12. That's going to give us 7/12. So the rule is subtract 3/12 or 1/4. Because a common denominator, a common factor to both 3 and 12 is 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So 1/4. All right, how about this one? We're going to start at 1/4 and add 3/8. So 1/4, 4th and 8ths. Well, I want to go ahead and change this one to help me add. I'm going to go 1/4 times something equals 8ths. Well, 4 times 2, right? All right, so 1/4 is the same as 2/8. I now need to add 3/8 to the 2/8. And 3 plus 2 is 5. Then we would have 8/8 and 11/8. All right, so 2/8 is the same as 1/4. Then we would have 5/8, 8/8. That's the same as 1. And 11/8. 11 divided by 8 would give us 1 and 3/8, right? The quotient is the whole number, the remainder is the numerator, and the divisor is the denominator. So 1 and 3/8. I'm going to put the word or underneath that. So this pattern and this pattern are equivalent. This one is just in simplified form. All right. Page 289, number 1. Write a rule for the sequence 1/4 to 1/2 to 3/4. Okay, well, we have 2 and 4. 2 can become 4. So let's turn 1/2 into fourths. To get 4, I'd multiply by 2. 2 times 1 is 2. So 1/4, 2/4, 3/4. Okay, well, it's increasing, right? So add, and it's just increasing by 1/4. Add 1/4. So to go from here to here, add 1/4. From here to here, add 1/4. And so we keep going. All right, number 2, 1/9 to 1/3 to 5/9. Well, I want to change the thirds so it matches the ninths. So 1/3 times what gives us ninths? 3 times 3. All right, so 1/9 goes to 3/9 goes to 5/9. Well, 1/9 to 3/9 is adding 2/9. To go from 3/9 to 5/9, we'd add 2/9. So the rule, add 2/9. All right, number 3. So on number 3, we're going to write a rule for the sequence, then find the unknown term. Well, it's easier to find the unknown, the rule if we change everything to the same denominator. So I'm going to go ahead and use a scratch piece of paper here. And so we have 3/10. And then we have 2/5. I want to turn 2/5 into tenths. 5 times what is 10? 2, right? So multiply the numerator by 2, so 4/10. So 3/10, 4/10. And then we have a gap. And then it goes to 3/5. I want to turn the fifths again into tenths. So 3/5 times 2 over 2. Now that gives me 6/10. And my last one is 7/10. So what is the pattern? Well, to go from 3/10 to 4/10, you just add 1/10, right? To go from 6/10 to 7/10, add 1/10. So the rule has to be add 1/10. So if I add 1/10 to 4/10, I get 5/10, which is the same as 1/2. One-half, which is the same as 5/10. All right, number 4. 10 and 2/3, 9 and 11/18, 8 and 5/9, a blank, and 6 and 4/9. Well, just looking at the whole numbers, it looks like it's decreasing. So my pattern is probably subtract something. So we have a 3, a 9, and an 18. Well, 3 times 6 equals 18, and 9 times 2 equals 18, and 18 times 1 equals 18. So let's turn all of these into 18ths. So 2/3 times 6 over 6, an equivalent fraction will be 10 and 12/18. Okay, so this mixed number, 10 and 2/3, is equivalent to this mixed number. Now the next one is already 9 and 11/18, 8 and 5/9. We're going to multiply the ninths by 2 to get 18ths. So that gives me 8 and 10/18. We have our blank, and our last one, 6 and 4/9 times 2 leaves me 8 and 6 and 8/18. All right, so what do we notice as our pattern? I don't know. Let's take the 10 and 12/18 and subtract 9 and 11/18. Well, 12/18 take away 11/18 is 1/18, and 10 take away 9 is 1. So we're subtracting 1 and 1/18. Subtract 1 and 1/18. So our pattern skipped from 8 and 10/18 to 6 and 8/18. So let's take the 8 and 10/18 and subtract 1 and 1/18. Well, 10 take away 1 is 9, so 9/18, and 8 take away 1 is 7. Well, 7 and 9/18 is the same as 7 and 1/2. Okay, so 7 and 1/2, which is the same as 7 and 9/18. Okay, number 5. Start at 5 and 3/4 and subtract 5/8. 5 and 3/4 minus 5/8. Okay, well, we have different denominators, so I'm going to multiply the 3/4 by 2 to get 6 and 5/8 to take away 5/8. 6 take away 5 is 1. So our next number is 5 and 1/8. And now we have to take 5 and 1/8 and take away 5/8. Well, we know we can't take 5/8 from 1/8, so we're going to rename the 5 whole as 4 wholes and add 8/8 to the 1/8. 9 take away 5/8 is 4/8. So 4 and 4/8. 4 and 4/8. Well, I recognize that 4 is half of 8. So 4 and 4/8 is the same as 4 and 1/2. I'm going to write 4 and 4/8 underneath there. And now we have to subtract 5/8 from that. Okay, well, I can't take 5/8 from 4/8, so I'll rename the 4 wholes as 3 wholes and add 8/8. So that's going to give me 3 and 12/18. 3 and 12/8, subtract 5/8. 12 take away 5 is 7, so 3 and 7/8. Number 6. We're going to start at 3/8, and we have to add 3/16. 3/8 plus 3/16. Well, I can turn eighths into sixteenths by multiplying by 2. So 6/16 plus the rule of add 3/16, we get 9/16. So 9/16. Now let's add 3/16 to that, and we'd have 12/16. But 4 is a common factor to both 12 and 16. So 12 divided by 4 is 3, and 16 divided by 4 is 4. So 3/4. And if you want, we can go ahead and write 12/16. And then we're going to add 3/16 to that. So 12/16 plus 3/16 is 15/16. 12 and 3 is 15. All right, number 7. start at 2 1/3 and add 2 1/4. Well, 3 is prime, so let's just multiply 3 times 4 to get a common denominator. All right, 2 4/12. Multiply the fourths by 3, and we'd wind up with 2 3/12. So we add that together, we get 4 7/12. Okay, so 4 7/12, and now we're going to add 2 1/4 to that. Plus 2 1/4. Okay, 4 I can make into 12s by multiplying by 3. Okay, 7 plus 3 is 10, so 10/12, and 4 plus 2 is 6. Okay, you notice that those are both even, so we can divide by 2. So 10 divided by 2 is 5, and 12 divided by 2 is 6. So 6 5/6, which is equivalent to 6 10/12. And add 1/4, add 2 1/4 to 6 10/12. Again, multiply the 1/4 by 3, so 2 3/12. So we have 8 13/12. We can't leave 13/12 like that, so let's divide. Subtract, we get 1. So our mixed number is 1 1/12. 8 plus 1 1/12 is 9 1/12. And number 8. This time we're going to start at 8/9, and we're going to subtract 1/18. 8/9 subtract 1/18. Well, 9 I can make into 18ths by multiplying by 2. And 10 take away 1 is 9/18. Well, 9/18, that's the same as 1/2. So 8/9, 1/2. If we subtract 1/18 from 9/18, that would be 8/18. And if we reduce 8/18, I can divide that by 2 and I get 4/9. And if I take 8/18 and subtract 1/18, I would have 7/18. Okay, I want to double check my answer. You know, those answers are not right. I'm not sure what I was thinking here. I think my brain I said multiply 8 times 2, and instead I added. So that's not going to give me the right answer. 8 times 2, that should have been 16/18. 16/18 divided by 2 is 8/9. Right? Okay, yeah. So should have been 16/18, take away 1/18. So I want to start this problem again. Sorry, guys. So 16/18 minus 1/18 gives us 15/18. We can reduce by 3. So we get 5/6. Okay, so not 1/2, it would be 5/6. Because that would have been 15/18. Now, 15/18, take away 1/18 is 14/18. 14/18 I can divide by 2 because they're both even numbers. 14 divided by 2 is 7, and 18 divided by 2 is 9. 7/9. Okay, 7/9. And if I take 1/18 away from 14/18, I'd wind up with 13/18. All right, I'm happier with those numbers. Okay, number 9. Vicky started jogging. The first time she ran 3/16 mile. The second time she ran 3/8 mile. The third time, 9/16 mile. If she continues, when was the first time she ran more than 1 mile? All right, so we started at 3/16. Then she went to 3/8. And then she finished at 9/16. We have to keep the pattern going until we get to a mile, which would be 16/16. So let's just make all of these into 16ths to make it easy to tell what our pattern is. 3/8. I can turn the eighths into 16 by multiplying by 2. So 3 times 2 is 6. So 6/16, 9/16. So what's our pattern? Well, from 3 to 6 is an increase of 3. So 3/16. To go from 6 to 9, it's increasing by 3/16. So let's just add 3/16 again. That gives me 12/16. If I add 3/16 again, 3/16 plus 12/16 is 15/16. And then plus 3/16, we'd be at 18/16. So when did she reach a mile? This one right there, right? So 1, 2, 3, 4, 5, 6 on the 6th day. And explain, well, we can just use our pattern. 3/16, 6/16, 9/16, 12/16, 15/16, 18/16. First, second, third, fourth, fifth, sixth. So on the 6th day, she ran more than a mile. Number 10. Mr. Connor drove 78 1/3 miles on Monday. $77 1/12 miles on Tuesday, and 75 5/6 miles on Wednesday. If the pattern continues on Thursday and Friday, how much fewer miles will he drive on Friday than Tuesday? Okay, so these are our numbers, and we have 3 and 6 and 12. Well, I know 3 times 4 is 12, and 6 times 2 is 12, and 12 times 1 is 12. So we can turn all of these denominators into 12ths. So 78 1/3 times 4 would be 78 4/12. Well, the next one is already 77 1/12. And then 75 5/6 times 2 would be 75 10/12. All right, so that's Monday, Tuesday, Wednesday, Thursday. Well, what's the pattern first off? It looks like it's getting smaller, right? So 78 and 4/12 minus 77 and 1/12. Well, 4 take away 1 is 3, so 3/12. So it's decreasing by 1 and 3/12, which is also the same as saying 1 and 1/4. So 75 and 10/12 minus 1 and 3/12 will give us Thursday. 10 take away 3 is 7. 75 take away 1 is 74. So Thursday we'd be at 74 and 7/12 mile. And Friday, 74 and 7/12 minus 1 and 3/12. So Friday, 73 and 4/12 mile. And it wants to know how much fewer miles from on Friday than on Tuesday. All right, so Friday, 73 and 4/12 mile. Tuesday was 77 and 1/12 miles. Okay, well, I can't take 4/12 from 1/12, so let's rename the 77 as 76 plus 12/12. So that's going to give us 13/12 minus 4/12. 13/12 take away 4/12 is 9/12, and 76 take away 73 is 3. So 3 and 9/12 or 3 and 3/4. A common factor of both 9 and 12 is 3. 9 divided by 3 is 3, and 12 divided by 3 is 4. So 3 and 3/4 miles, fewer miles. 3 and 3/4 fewer miles. 290. When Bill bought a marigold plant, it was a 1/4 inch tall. After the first week, it measured 1 and 12 inches tall. After the second week, 1 and 11/12 inches. After week 3, 2 and 3/4 inches tall. Assuming the growth of the plant was constant means the same, what was the height of the plant at the end of week 4? Okay, so it started at 1/4. At the end of 1 week, it was 1 and 1/12. At the end of week 2, 1 and 11/12. At the end of week 3, 2 and 3/4. Okay, so the 1/4 is not a week. That's what it was when he bought it. So week 1, week 2, week 3, we have to find week 4. Well, to go from here to here, that's an easy one to tell. 1/12 to 11/12 is 10/12, or divide by 2, 5/6. Okay, to make it, so 2 and 3/4 plus 5/6. I know I can turn 6 and 4 both into 12s. So 2 and 9/12. So 10 plus 9 is 19/12, and 2 plus nothing is 2. I can't leave 19/12 like that, so I'll divide 19 by 12, which is 1. Subtract, I'm left with 7. So 1 and 7/12 plus 2. 3 and 7/12 inches. All right. Number 12. So what if Bill's plant grew at the same rate, but was 1.5 inches when he bought it? How tall would the plant be after 3 weeks? Well, all right, so he's buying the plant and it starts at 1.5. It's going to grow the same 5/6 of an inch. So 1/2 is 1.5 is the same as 1 3/6. Plus 5/6 is 1 8/6. If we add another 5/6, so 1 8/6, that's the same as 2 2/6. 8 divided by 6 is 1. Remainder would be 2, so 2/6. 2 2/6 plus 5/6, we would have 2 7/6. 7 divided by 6 is 1. Subtract, we get 1 left, 1 1/6. 1 1/6 plus 2 is the same as 3 1/6. How tall would the plant be after 3 weeks? Well, right now we've only gone 2 weeks. So we need to add 5/6 to the 3 1/6. So 3 1/6 plus 5/6. 5/6 plus 6/6 is 1. So we'd be at 4. So 4 inches tall. 13. Kendra hiked each day for a week. The first day, she hiked 1/8 mile. Second day, she hiked 3/8 mile. And the third day, she hiked 5/8 mile. What is the rule for the distance Kendra hikes each day? Show how you can check your answer. Okay, so we had 1/8, 3/8, 5/8. Well, to go from 1 to 2, that's just going to be 2/8. To go from 3 to 5, that's going to be 2/8. So the rule is add 2/8 or 1/4. So if we start at 1/8 and we add 1/4, that would be 1/8 plus 2/8, which is 3/8. 3/8 plus 1/4 is the same as 3/8 plus 2/8, which is 5/8. And 5/8 plus 1/4 is the same as 5/8 plus 2/8, which gives us 7/8. So if we just keep adding 2/8, so 1/8 was week 1. When we added the 1/4, we got 3/8. So first day 1/8, second day 3/8, third day 5/8. 1/8, 3/8, 5/8 matches the information in the problem. If the pattern continues, how many miles will Kendra hike on day 7? All right, so day 1, 1/8. Day 2, 3/8. Day 3, 5/8. Day 4, 7/8. Day 5 will be 9/8. Well, 9/8 is the same as 1 1/8. Okay. 9 divided by 8 with a remainder of 1. So 9 divided by 8 is 1. I'd have a remainder of 1, so 1 1/8. 1 1/8 plus 2/8 is 1 3/8. 1, 2, 3, 4, 5, 6 days. And plus 2/8 1 and 5/8. So 1 and 5/8 miles on day 7. All right, we got the answer just by adding 2/8 more mile each day. Okay, so that's it for patterns with fractions. In our next lesson, we're going to be working with problem solving, using our skills in adding and subtracting fractions. So until then, I will see you soon.